Good day everyone, this is Sarel van Grenen, aka Mr. VG, and I am stoked today to be here with you all. It's my first live stream, so I ask you be patient. If there's some technical glitches, please stay with me. Well, you might be wondering, what are you doing here? And if that is you, you're here for mathematics. You're here for functions, graphs, and inverses. And we are here to help you conquer that dragon of mathematics. So, welcome. I hope you're going to enjoy this live streaming session with me. I'm going to aim to be finished in 45 minutes, an hour maximum. And today I'm going to work through 3 exam type questions. 3 questions that actually came up from previous year's exams. So please, enjoy. Enjoy your time here with me. Enjoy your stay. Please remember you can pause the video anytime. Maybe rewind a bit if you get stuck somewhere. And this video will also be made available later on. So I want to welcome you all to this lovely, cold Saturday afternoon. Let's jump into our first question. Now, our first question comes from the Department of Basic Education. They wrote a lovely paper end of last year, and we're going to do this. If you haven't yet received the question, feel free to click on the Show More button at the description, click on the link for question 1, and it will come up in the new window. But let's dive in. So, ladies and gents, this is our first question. Let's just first read through the question. The question states, sketch below is the graph of f of x equal to k to the x, with k being bigger than 0. The point 4, semicolon 16 lies on f. And there they gave you the sketch of f. Now, before we actually get too far into this, I want to encourage you to remember your basic theory. Now, from the sketch, if I look at the sketch, I can automatically see that k is larger than 1. The reason for this is if you look at the asymptote, which is that line there, the x-axis, my graph tends to go away from the axis. It diverges. And therefore, I kind of know that k must be bigger than 1. But let's jump into this question. It's a relatively easy question. You shouldn't have much trouble with it. So right at the beginning, to calculate a value that I cannot read off, like in question 5.1, I simply take my coordinate and I substitute in. So in other words, I make x 14, or 4 I mean, and my y value 16. In other words, 16 equal to k to the power of 4. To get rid of that power of 4, we take a 4th power root on both sides, leaving me with k equal to 2. Now, very theoretically, you've got to remember, because it is an even power root, that I must actually put a plus minus in front of the k. But because they did tell me that k is larger than 0, it's not really necessary. So there you've got 5.1 done and dusted. Now when I look at question 5.2, question 5.2 reads, graph G is obtained by reflecting the graph f about the line y equal x. Now the moment I read that about the line y equal to x, my thoughts automatically goes towards inverses. So, what do I do with the inverses? That's the big question. Well, with the inverses, we've got to remember from the theory that y becomes x as well x becomes y. So they do a big swap. So in my equation, which is y equal to 2 to the power of x, that is for f, to get the inverse, I'm going to swap x and y. In other words, x is equal to 2 to the power of y. But we haven't answered the question, and that's a very important thing. With functions and graphs, always make sure you answer the question. The question is, make y the subject. So in other words, I want to get y alone, so I'm going to use logarithms. So y is equal to log base 2, because the 2 remains the base, of x. And there you've got the graph of g. Remember, let's just label this now g of x. And that is equal to log base 2 of x. Simple and straightforward. Remember, if you get stuck somewhere, if I'm going maybe a bit too fast, you can always just pause, rewind a little bit, and rewatch what I'm doing. For question 5.3, it now says, sketch the graph of G. Now, to sketch the graph of G, I am going to first of all just draw a rough sketch for myself of F. Now, F is that line there, which has the coordinates 1, and on there as well, 4, 16. What do I do with inverses? Swap x and y around. In other words, 0, 1 becomes 1, 0. 4, 16 becomes 16, 4. Unfortunately, my sketch is really not up to scale, but in the exam, it's not really an issue because the examiners don't look for scale. They look for form, they look for coordinates, they look for special coordinates, asymptotes. So I'm just going to plot it here. 1, 0. There we go. There's my 1 coordinate, 1, 0. And then as well, my other coordinate will be somewhere randomly there, which is the coordinate 16, 4, which means I can draw my graph of g of x on my Cartesian plane. There I have it, plain and simple. Remember, it's 4 marks, so you should spend 3 to 4 minutes on it. But it's super simple. If you already have g, or if you already have f, then you just swap x and y to get g. I'm going to move over to a new slide. Remember, you can hit the pause button and copy down, or you can just rewatch the video. So let's go over to question 5.4. Now, for question 5.4, I am going to just redraw my graph of f and g quickly because I need my interpretations. I need them for my interpretations. So there I've got the 1, there is f, there's g with 1. Okay, I actually am only going to use that one there. So the first question at question 5.4, so 5.4.1, asks me where is fx times by gx bigger than 0. Now, whenever I get an interpretive sum like this, I love to use different colors. So for f, I'm going to use the red. So I could have red with a plus, and for g, which is going to be my blue, could be a plus times by a plus. Or it could be a minus times by a minus. Let me just make that a bit bigger. There we go. That's my two options to end up with a positive. So to end up with that positive, let's go to my graph. Let's go and have a look. So I'm going to start with my red graph, which is the original fx. And I'm going to look at where is the graph positive or negative. Well, the interesting thing actually is my graph, the y values are always above 0, so they are always positive. What does this mean for my equation or for my inequality? Well, the second one is not an option anymore because the red can never be negative. If I look at the blue, on the other hand, between 0 and 1, I've got this band here where my graph is negative the whole time. The moment it goes past 1, it starts to become positive. Okay, what we can do now is we take our graph and we kind of divide it into the different sections we have. First of all, we have this section on the left of my y-axis, where g of x actually doesn't exist. So whatever I answer, I must remember that g of x does not exist here at all. Then the second band, can I say, the second set of domains is between 0 and 1. There I have a negative, a blue negative, times by a red positive. That's not what I'm looking for because that gives me a negative answer. Then from 1 onwards, I have a blue positive times by a red positive. Oh, fantastic. That's what I'm looking for. So I'm not looking for between 0 and 1. I'm not looking for smaller than 0. I'm only looking for this domain from 1 to infinity. And there you have your question 5.4.1. X larger than 1, or if you like your interval notation, x can be between 1, your smallest one. Let me just make that a bit larger. So x can be from 1 to infinity. Now 1 is not included because they didn't say equal to 0, and infinity is never included. Therefore, it always gets a round bracket. Whichever one you want to use in the exam, the examiners do not mind. But please remember, g of x, the domain of g of x is restricted. So you cannot look smaller than 0. If you don't really understand where that comes from, please, I encourage you to ask your teacher, ask your center manager, and let them explain it to you. If you're not coming right there, please, at the end of the video or the end of the live stream, I will share with you an email address where you can send all your questions or queries. Let's go over to 5.4.2. Now 5.4.2, for me, when I did it, it was kind of an interesting question. So the interesting question was, where is g of x smaller or equal to -1? In other words, where are the blue y values smaller or equal to 1? The only issue I have here is I don't have an x value, and they're asking me for an x value. So what I kind of thought about doing was, let me get an x value. Let me get where is y equal to 1. So I can go to my sketch and look where y is equal to 1. So I'm going to go 1 is equal to log base 2 of x. Okay, my apologies. I have to use -1, not +1. I'm glad I picked that up quickly. So let me quickly solve x. So x goes on its own. The -1 goes into the exponent. So in other words, x is equal to 2 to the -1, which is a half. Now, if I go back to my g of x sketch that I'm just quickly going to draw here for you. If I go back to my sketch, it means when y is -1, the x value there is about 1/2. So now the question is, where is the y values of g smaller than 1/2? Now, what part of this graph is actually now colored in? Well, it is that little band here between 0 and 1. So in other words, my answer for x is between 0 and 1. Now, x cannot be 0 because that's an asymptote for the logarithmic graph, but it can be equal to 1 because they did say smaller or equal to, not 1, sorry, my apologies, mustn't be 1, it must be 1/2. So x is between 0 and 1/2. Now I've got it right. And I want to encourage you to look at the way that I approach this. And I made a mistake now, and that's fine. I fixed it. That is the important thing, ladies and gents. You are going to make small mistakes. You are going to make little errors. That's okay. Learn from your mistakes and just correct them like I did here now. I'm going to go over to question 5.5. This question 5.5 is the actual reason why I chose this specific question. Now, question 5.5 brings in a lovely, lovely new thing. It tells me a new function, h of x equal to f of negative x. Now, h of x equal to f of negative x. What I just like to do before actually attempting it algebraically, I personally like to look at what does it mean. It means for the f function, I took the normal x values and I made them negative x. Which means, if I go back to my theory, that it is a reflection in the line y, or in the y-axis. There we go. I just like to do that because no matter what they then ask me, maybe they ask me an interpretive question, but then I look at my graph. It's not going to make much of a difference. So what I'm going to do is I'm going to just run into question 5.5 head first and let's see where we go. So in other words, they're asking me fx minus f minus h of x, let me just hold back with that one, is equal to 15/4. Now let's quickly think. H of x is actually f to the negative x. Algebraically, that means replace every x with a negative x. In other words, 1/2 to the x. I like to simplify it because I might use it later on. So what I'm going to do is, in the place of fx, I'm going to put 2 to the x. In the place of h of x, I have 1/2 to the x. This is equal to 15/4. Oh wait, what am I sitting with here? This is a grade 11 exponential equation that I've got to solve. I hope you still remember how. If you don't, well, it's maybe now a good chance to pay attention. In a case like this, ladies and gents, I love to do the k method. In other words, let 2 to the x equal to k. So I'm going to sit here with k minus 1/k equal to 15/4. And I'm going to try and solve this. So I'm going to get rid of my fractions by multiplying by the LCD. Let me do it in a different color for you. I'm going to times by 4k, which is my LCD. And I'm going to times by 4k. And I'm going to times everything by 4k. So in other words, k divided by k is 1. 4 divided by 4 is 1. So in other words, I'm going to sit here with 4k squared minus 4 equal to 15k. Now this is a nice algebraic equation, which means that I'm going to solve it by putting it equal to 0. Let me do 15k minus 4 equal to 0. I'm sorry, it seems like I'm running out of space here, but I'll make a plan now. If I factorize this correctly, I've got 4k in the one bracket and k in the other bracket. Now I want to get to a large number, so I want to get to 15 as my middle term. So I want 4 times 4 if I multiply out my brackets. And I want a 1 there, a minus and a plus. Please feel free to use your quadratic formula. Even if you've got that fancy Silver 991 calculator, the Casio, you must show the examiner either factorization or substitution into the formula. So let's go over to solving this. If I look at this new one, and I'm just going to do a nice bracket here on the side for myself, I'm going to get 2 possible solutions. K equal to negative a quarter, which means 2 to the x is equal to negative a quarter. But is this possible? No. Okay, just want to make sure, yes, it's not possible because 2 to the x cannot be a negative number. My second possibility is k can be 4. Let me write a big or there. In other words, 2 to the x is 2 to the 2, which leads me to x being 2. And there you've got that question. An absolute beaut of a question. An absolute beaut. I love this. I love this. Now, ladies and gents, before we go over to the next one, I really want to encourage you to take your time with a question like this, question 5. If I look at the marks, it's a total of 2, 4, 8, 16 marks, which means in the exam, if you can do that in anything less than 20 minutes, you'll be fine. If you can do it quicker, go for it. Now, I'm taking my time with this sum simply to explain to you what I do, how I do it, how I think about doing it. I encourage you, please, go to your teacher if you're struggling. Find some ways, find someone that can help you. Do not be stuck in not understanding a question. I'm going to go over to this next question. This next question, ladies and gents, is a bit more of an interesting question. I picked this next question from a school in Joburg. So shout out to Red Hill. Thank you for providing me with this lovely question from your last year's prelim paper. This was actually not in the functions and graphs section. It was actually in question 1 of their paper. Now, this question reads, the diagram above shows f of x equal to negative 2x squared minus 5x plus 3. Now, please just hold back before you run into this question. Before I actually do anything, I love to interpret anything that I know about fx. First of all, the a value is smaller than 0, which means it is a frowning parabola. Also, the c value is 3, which means that my y-intercept, if I wanted to know that, is 3. There I've got all the information I have that I need at the moment. Now, question C. On purpose, I didn't do A and B because it was simple solving of X, those kind of questions. But question C is a beautiful, lovely question. If P of X is equal to negative X plus T, find T if F of X and P of X do not intersect. What do they mean? Well, if I look at the graph, well, P of X is a negative gradient. In other words, a negative gradient of 1. In other words, they are looking for values of T that the graph would look like the one that I just drew. There's no intersection between Fx and Px. So what do? I'm going to teach you a lekker trick, a beautiful trick when it comes to mathematics. Is whenever they ask me in an exam, where does something not intersect or prove that it cannot happen, assume that it does happen. So how do I assume that they do intersect? Let's think about that. How do I get where two graphs intersect each other? Well, plain and simple, I take Px equal to f of x. That is for intersection between two graphs. So to do intersection between two graphs, I'm going to take Px, which is negative x plus t, equal to fx, which is negative 2x squared minus 5x plus 3. Now that is not a nice equation, but it is definitely not impossible to solve. So let's have a look at how do I prove that they can actually not intersect. Well, let's think about it. When will a quadratic equation have no solutions? Because if I can prove that this equation has got no solutions, it means that the graphs do not intersect each other. In other words, let's see. Let's get it into standard form. Negative 2x squared minus 5x. Well, I'm going to take that negative x over and it becomes positive x, which means I am going to be sitting with negative 4x. And I'm going to take the plus t over as well, and it's going to become negative t. Look at what we've got here. We have a quadratic equation. How do I prove that a quadratic equation has got no solution? Let's think back about grade 11, nature of the roots. If I can prove that if I have the delta is smaller than naught, your discriminant, well, then there won't be any solutions for this. So in other words, let's just backtrack. The monkey behind the mountain. My monkey is that I want to prove that there's no solutions. The way to do that with a quadratic equation is to look at delta smaller than naught. There is actually my second mountain. My first mountain is getting it into standard form. The second mountain is I want delta smaller than naught. That gives me the third mountain that I want to know what delta is. Now I've got to remember that delta is equal to b squared minus 4ac. So in this specific equation, there is A, there is B, and there is C. So if I substitute in, B is negative 4, so that's going to be negative 4 squared minus 4 times A, which is negative 2, times by C, which is 3 minus T. So delta is equal to 16. Let's multiply out. That gives me plus 8. And if I multiply that 8 Let me maybe do it in a different color for you. That gives me plus 8. If I multiply the plus 8 in, I get plus 24 minus 8t. So my simplified expression for the discriminant is equal to 16 plus 24, which is 40, minus 8t. Now I've got an expression for delta. I want to know, where do they not intersect? In other words, where there are no solutions or non-real solutions. And that happens only when delta is smaller than naught. So I'm going to say 40 minus 8t is smaller than 0. Now you go and solve this. I'm going to solve it by taking the negative 8t over. So 40 is smaller than 8t. Divide both sides by 8, which means t must be, let me write it, 5 smaller than t. So in other words, if I just write it in nice format, for t larger than 5, there will be no solutions for the intersection. So there won't be an intersection. The moment that my y-intercept of px, that t value is anything above 5, then there won't be solutions. They will never intersect each other. Smaller than 5? Well, smaller than 5 there would be. Smaller or equal to 5, actually, let me correct myself. There will be solutions. 1, maybe 2. I'm not going to worry much about that now because I've answered the question. Because the question was, find t. So in other words, what are the values of t? Now, let's have a look at d. D kind of goes into the same space as C. But now they give for me a value of t, which is now 5. So let's try D. When I look at D, where they intersect is h of x equal to p of x. Sorry, where do I get my p from? H of x equal to f of x. So h of x is equal to negative x plus 5, and f of x is equal to negative 2x squared minus 5x plus 3. Now let's just solve this. I'm going to run into this, get x equal to 0. So in other words, negative 2x squared minus 4x, because I take the negative x over, and I do the same with the 5. I take it over and it becomes negative 2. Again, you could do it whichever way you want to. I'm going to divide both sides by negative 2. So it becomes x squared plus 2x plus 1. If I factorize this, I get x plus 1, which means that x is equal to negative 1. Oh, wait, I only have one solution. Oh, that's fantastic. Which means I will only have one y value. So if I have one y value, let's use the easiest one, which is h of x in this case. H of negative 1. Now, h of negative 1, negative 1 plus 5. So my answer is 6. Which means the graphs intersect at negative 1, 6. Now, did we answer the question? Not really, because the question consisted of two sections or two parts. The first part was solve simultaneously. The second question was, what can you deduce about h of x? If I look at h of x and it only has one solution, it means h of x is not just any line. It's actually a tangent. It's a tangent to f of x at x equal to negative 1. because it touches it only once. This means it won't cut twice. Here comes a very important thing to remember. Everything you do algebraically, ladies and gents, always interpret your questions. Always have a look. What does it mean for the graphs? What does it mean in the sketch? Especially if they ask you, what can you deduce? Remember to hit the pause button if I'm going a bit fast, or if you are struggling to understand, I encourage you to please ask questions. Go to someone that, a teacher or a center manager. Ask questions if you are struggling with these things. I'm going to move over to the next question. The next question, ladies and gents, I got from, let me just quickly get there. I can't remember exactly which paper, but it was a previous year's exam paper. I think it was an IEB supplementary paper that I got this one from. This was an absolutely beautiful, beautiful question. The graphs of a quadratic function f of x equal to ax squared plus bx plus c and g of x equal to d over x plus q for x bigger than naught are sketched below. Let me just quickly take a sip of water. There we go. So they give you the graph. Now automatically the graph of f and g, I want to interpret before I do anything. So for f, I know that a must be smaller than naught because it is a negative parabola, or parabola with a negative shape. The concavity is negative. I know that the c value is bigger than naught because of the positive y-intercept. So c is bigger than naught. The reason why I do this, just quickly, is so that whatever my answer is, it has to conform to these two things. Otherwise, I'm pretty much sure I made a mistake. So let's go into that question, or into the further information before we go to the question. So first of all, they give me f of negative 1 equal to naught. That means it is an x-intercept. Then they give me f of naught is 3. Well, that is a y-intercept. And lastly, they give me a set of coordinates. 1, 2. I'm sitting with an issue. Because usually in the textbooks and in all the exams we do, we either give you the two x-intercepts, then you use the form of y equal to ax minus x1, x minus x2, or they give you the turning point. So, sorry, this is for the x-intercepts. Or they give you the turning point where you use y equal to a x minus p squared plus q. They give you usually one of the two. But in this case, they don't give you either. They give you 3 semi-random points. They don't give me the two x-intercepts. They don't give me the turning point. So now what? Now I'm kind of running out of options. So what I'm going to suggest is when you run out of questions or suggestions, just jump into it. Substitute points in and look where you can actually go. When I look at substituting coordinates in, I actually always start with my y-intercept because then usually a lot of things disappear. So in other words, I'm going to start with f of naught. So a times naught squared plus b times pi naught plus c, and this must be 3 because they did tell me it's the coordinate 0, 3. Lovely, because only c is left. So in other words, I have that f of x already is equal to ax squared plus bx plus 3. Now in this case, what I now need to do is look at the other coordinates. I'm going to go to the x-intercept because maybe something else disappears. So in other words, f of negative 1 is 0, which means if I substitute negative 1 in, negative 1 squared plus b times negative 1 plus 3 is 0. So in other words, I have a minus b, and I'm going to take the plus 3 over, and it becomes negative 3. I've got one part of where I want to go. Then I'm going to look at the other one, f of 1 equal to 2, because they told me that it's the other set of coordinates. In other words, substitute 1 into a, 1 into x, and I have this equation 2 equal to, and if I solve this, I get negative 1 equal to a plus b. Now what am I going to do? I've got two sets of equations. Now I can simply solve them. I'm going to take a shortcut. You don't have to do this, please, but I love this. I'm going to take the first equation and add it to the second equation. If I take the first equation and I add the second one, adding on the left, I've got negative 3 plus negative 1, so it's negative 4. On the right, I've got a plus a, which is 2a, and negative b plus b, which is 0. Oh, brilliant! The b's just went poof, gone. So in other words, a is equal to 2. Negative 2, I mean. Let's just quickly backtrack. Does this conform to what we said initially? A must be smaller than naught. Yes, it does. I've got a good feeling about this. Now I need to go towards b. So I'm going to substitute this into any of the two. So negative 1 is equal to negative 2 plus b. So b is equal to 1. Now let's just quickly look at what the question asked. The question specifically asked, where is, or determine the values of A, B, and C. Did I answer that question? Yes, I did. Yes, I did. So I know that I'm done with this question. If they actually asked me, but what is the value, or give the equation, I would have had to write f of x equal to that. Let's quickly move on to the B part of this question. The B part of this question is, where is, or determine the values of x for which the graph of fx is decreasing. Now I know that you can do calculus on this. For those of you that have done calculus, you can just say first derivative smaller than naught. But I'm going to look at calculus only in the next one. So what I'm going to have a look at is splitting my graph in two. Where is fx decreasing? So in other words, where's my graph going down? But for that, I actually need the turning point. I need the axis of symmetry. So I'm going to use x equal to negative b over 2a. Let me just write that a bit better. X equal to negative b over 2a. Please feel free to use calculus. First derivative equal to naught. I'm just going to go for this. So negative 1 over, or is it positive 1? Let me just quickly go back and check. Yes, it's positive 1. My apologies. Over 2 times by negative 2. So in other words, I've got 1 over 4. So in other words, for all x on the right of a quarter, my graph is actually decreasing. It is going down. Could have found that much easier by using calculus, right? First derivative smaller than naught. Let's go over to the C part of this one because I'm running out of time. I want to try and finish as close to 5 minutes to 2. So let's jump into question C. Now question C asks if the graph of fx and gx intersect at the point x, comma, -3. That means I don't know what x is. Let me do it in a different color. But I do know what the y values are. Okay, I've got 1/2 of this thing solved. And it has a horizontal asymptote of y equal to -2. Now this is lovely because it automatically gives me the q value. Q is -2. If I look at this now further, let's write down what we've got. G of x equal to d of x minus 2. Now the question is, determine the value of d. There's my monkey. P.S. If you don't know what the monkeys and the mountains are, please go and rewatch or go and watch the video on the good approach to mathematics. That is the first video in this series of functions, graphs, and inverses on the Junior Tucky page. And there I talk about the monkey behind the mountain. And we are also doing a course on mathematical reasoning where I'm going to explain in detail the 3 different approaches that we have towards mathematics, problem solving, mathematical reasoning, whatever you want to call it. We do 3 basic approaches to mathematical reasoning. So let's jump. Let's go. But before we go, what are they asking me? They're asking me for D. Now D is that point or is that value there at the top. If I look at D, I always ask my students, can I read it off from the graph? I know, I can't. The only thing I know is that D lies in the graph lies in quadrants 2 and 4, which means D is some kind of negative value. Okay, that's because it is a hyperbola in the 2nd and in the 4th quadrant. I don't really know anything more. So I need a set of coordinates that I can use to calculate that value, that missing value. So to get D, I need a set of coordinates. Well, I do have that y is equal to -3. Do I have an x value? The answer is no, I don't. So in other words, I don't know what that x value is, but I do know that fx and gx intersect each other. So in other words, f of x must also be -3. So if I substitute fx in, -2x squared plus x plus 3 equal to -3. This means that let's take everything to the right. I'm going to sit with 2x squared minus x minus 6. 0 is equal to, let's factorize, 2x and x. I'm going to go 2 and 3 minus and a plus. Again, use the formula if you get stuck with this factorization. So x is either at -3/2 or at 2. But now you've got to kind of be careful. Look back at the original question. The original question said or stated that x must be positive. So in other words, -3/2 is not a possibility. So x must be 2. This now, ladies and gents, leads us towards our last little bit for today. Let me do a separate section here. I have now that g of x, which is d over x minus 2, passes through 2, negative 3. So I'm going to substitute y with negative 3, and I'm going to substitute x with 2, and I'm going to solve for d. So I'm going to take that negative 2 over. It becomes plus 2, so negative 3 plus 2 is negative 1 with d over 2. So I'm going to times by 2 on both sides. And this gives me that d is equal to negative 2. You've got to ask yourself this question now. Does this conform, or is this true for this specific sketch? Now, I talked about this. I alluded to this, that d must be smaller than 0 because d lies here. Let me do it in green, in the 4th quadrant. And if we looked at x smaller than 0, it would have laid there, which means d is smaller than 0. D is equal to negative 2. Yes! I've got this. I've got this. And therefore I know I've answered the question as well, because they did ask me specifically the values of d. Ladies and gents, what we need to do is continue practicing. I'm going to end off today, and I'm telling you, it was fantastic to have all of you here. If you know of some people that missed it, that didn't get this, please ask them to go and relook this. Ask them, because this will be made available online. I'm going to cut it up maybe in a few smaller videos so that it's not almost an hour long. Remember, subscribe to the channel. Click on that bell for the notifications so that we can give you any notification for a new video coming up. So what is coming up in this next coming few weeks? First of all, next week, we are going to do a live session on physical sciences. And for that, we have Dr. Sarita Swanepoel, fantastic physics teacher. And she's going to cover the first cycle of physical sciences. And please send her questions. I'll tell you guys now about where you can send the questions. Next week, I'm going to give you pre-recorded videos about calculus. Whatever questions you have, please send them through to us. Please let them come to us after you've asked your teacher the question. Or let's say you've got a beautiful mathematics question and you are struggling with it, or your teacher just says, this is lovely. Please send it through to us. I would love to answer it next week on a pre-recorded video that will be made available on Saturday morning. If you are new to the program, or if you are not sure about what we are doing or how it works, please click below on the show more. Click there and get the link to the program. It's given to you. On that link, it will take you to the University of Pretoria's website. There we will have links to videos. There's worksheets with memos for both the mathematics and the physical sciences. We have theory that was compiled by us that you need to conquer this dragon of mathematics. Check the space, because we will be developing new content. We are looking at expanding this project to take it as far as we can possibly do. If you know of someone that really needs this, or you know of teachers that maybe want to show this to the class, tell them to subscribe to the Junior Tucky channel. Hit subscribe. Remember that bell for the notifications if you want to receive it. Go and have an absolutely wonderful rest of your Saturday. I'm looking forward to seeing you all again in 2 weeks again. 2 weeks for that live streaming of calculus. The calculus and physics questions, you can send them to Junior Tucky or junior.tucky@up.ac.za. It's in the description below. Remember to click show more. Have an awesome, wonderful rest of your Saturday.